Sequences and series, let's start off with some definition. What is a sequence? Sometimes called a progression rather than a sequence. So sometimes you'll hear it called, instead of an arithmetic sequence, you'll see the term arithmetic progression. But it's basically a set of numbers that's following some sort of pattern. As opposed to series, so it's a subtle difference. A series is, instead of just listing the numbers, we put a plus sign in between them all. So it's when you add all those numbers up in the pattern. That's when we call it a series rather than a sequence. Very creatively, we came up with A to represent the first term. Now, how we thought of that, I don't know, but there we go. But other than that, when we have any particular term, we just say term with a subscript of whichever number. So I suppose technically, instead of using A, you could write it as T1, but no one ever does that I can think of. Whereas if I'm talking about the series, so the actual sum of when I add them all together, then we replace it with an S. We say sum of however many terms. So an example, here's a formula to work out our pattern. It's telling me I can work out any term by getting n squared plus 2. So if I had to find the fifth term, it's just a substitution question. 5 squared plus 2, 27 we get. But now I can answer some questions. Well, you're telling me that's the pattern. Is 42 a number in that sequence? So in other words, let's solve this equation and see what we get. And we end up with n is the square root of 40, which is of course an answer, but not a good answer for our question because n's representing a particular term. It's got to be a positive integer, and that's not. So that's no good. That means 42 can't be in that particular sequence. Then we have recursive formulae. That defines the pattern in a different way, but in terms of previous terms. When you have a formula for it, what they'll tell you is they will tell you the starting term of the sequence. Or it might be the first couple of terms, but they'll tell you some terms that are actually in the sequence. And then they'll give you some expression which will allow you to generate all the other terms. So something like this. Here's our pattern. Now we're saying the first term is going to be the number 4. We're going to generate every term by getting the previous term and adding 3 to it. And they're telling me, well, this formula is good when n's greater than or equal to 2, because clearly I can't use the formula for when n's 1, because I don't have a 0th term. I mean, what's that? If I want the first 4 terms, you told me the first one was 4, I'll add 3 to that, the next one must be 7, and the next one 10, the next one 13, and so on. But you can get more interesting patterns. This is known as the Lucas numbers. It's very familiar, but it's something different because it looks like the Fibonacci sequence. The actual generation, the actual recursive formula is the same, where you get the 2 previous terms and add them together. But the difference between the Lucas numbers and the Fibonacci numbers are the starting numbers. You may recall the Fibonacci numbers start with 1, 1. The Lucas numbers start with 2, 1. But that's the only difference. So if I have to find the first 5, alright, well it's 2 and 1. To get the next one, I add the 2 previous. 2 and 1 is 3. 3 and 1 is 4. 4 and 3 is 7. So that's how the Lucas numbers go. Now we're going to be interested in 2 very specific types of patterns. The arithmetic, which we'll look at now, and then the geometric ones as well. Arithmetic series, it's sequence of numbers, very simple one, just by adding a constant amount to the previous term. That constant amount we add, we just call it the common difference, symbol D. So that common difference I could work out, if I had the second term, I just subtract the first term and that would tell me what the common difference is. Or if I had the third term, I could subtract the second term. It'll tell me what the difference is. And in fact, I could pick any term I like, as long as I've got 2 consecutive ones there, and I can subtract them and get the common difference. But what that now allows me to do is I could create a recursive formula for an arithmetic one. If I just rearrange that and make term n the subject, there's my recursive formula. I'm just saying, oh well, it's the previous term and I'm just adding the common difference. So that would be the recursive formula for an arithmetic series. Alright, well term 1 we said was A. Term 2, well, we add a difference on, A plus D. Term 3, A plus 2D, and straight away we start seeing a pattern. So we know that actually any term we could get using this general expression, A plus n minus 1D. And there's our general term for an arithmetic series. We want to work out what the formula is, and they haven't given us two consecutive ones. So I can't use this idea of d equals, and I'll just subtract. But that's okay, because what I do know is, well, term 3 must have been a plus 2 common differences, and term 7 must have been a plus 6 common differences, and essentially I've just got a very simple simultaneous equation to solve. That tells me, the common difference is 3. I can sum back in, by coincidence the first term is also 3. Sub that into our formula for the general term. Well, that is a formula for the general term, but we don't leave it like that. We can tidy that up and make it look better. And when we tidy it up, it's simply just multiples of 3, this one. 3n would be our pattern. And if they then said, what's the 100th term? Not a problem. Now we've got our general term. 3 hundredths, that's 300. We know what it is. But what would the first term that's bigger than 500 be? What we're now saying is, which term n, is bigger than 500? That's essentially what we're trying to solve. So when is 3n bigger than 500? Well, 500 over 3. But we want a positive integer. So I'm looking for the first one that would be bigger. And that's 167. So how do I answer that question? The question says, what is the first term? So is it good enough to just say, the 167th term? Because, does that answer the question? I guess it does, because they've said, what's the first term greater? The 167th term is the first term greater. It's probably better to actually write what the number is, though. So I put both usually, just to avoid any confusion. It's the 167th term, which is 501. That's going to be the first one that's bigger than 500. And then there's no confusion about what they might have been asking me in the question. Okay, if you were to plot these numbers, you should end up with a linear function, because have a look at the formula. A plus n minus 1d. It's like y equals mx plus b. It's the same sort of idea. So we would get a linear function if we were to plot these things. Alright, that will do us to start off with. So 1a and 1b. Let's have some fun.